Okay, welcome to this video on the types of volume questions you can get at National 5 level. Now, I'm going to run through maybe 4 or 5 volume questions, and they're all slightly different. Doesn't really matter the shape, it's the type of questions we're concentrating on. So you'll see that these 4 or 5 type questions, that when you come to your exam, you will get one of these type. Okay, so we're going to start off with the basic type. In the exam, you usually get a very basic one at paper 1 and then a more complicated one in paper 2. Important things about the volume questions are at the end of the question, you usually get tagged onto it, write your answer to so many significant figures. So there's usually a mark at the end for that type of thing. Okay, so let's look at the most basic type they can give you. Well, we're looking at here as a cone shape, and we have to work out, the question says, work out the volume of that cone. Now, you couldn't get any easier than that in the exam. A simple shape, and you have to work out its volume. Now, for the exam, you will be given formulas for volume for shapes that are not a prism shape. Now, a cone is not a prism, so you'll be given that formula. But if it was a cylinder is a prism with cross-section area of a circle times its height or its length, depending on how it's lying. You're not given that type of volume formula because you're expected to be able to work that one out. Okay, so back to this question. The question is volume of this cone. So the formula will be in your formula sheet is V equals a third pi r squared h. So you write that down and then it's just a matter of plugging in your numbers. But if you look at it here, we need to find the radius. Now it's 6.4 for the diameter. This is the diameter all the way across the base here is 6.4. So we have to half that, so the radius is 3.2. And we square that and we times that by 10. And all you have to do from there is work that out. So just take a wee second to work that out. So that's a third times pi times 3.2 squared times 10. And according to my calculations, that comes to 107.23 to 2 decimal places. So 107.23, and that'll be cubic centimetres. Now in the question it says to two significant figures. So the first significant figure is 1, the second one's 0, but there's a 7 beside it, so that changes to a 1. So 110, we don't need the decimal part of it, cubic centimetres. So to two significant figures, that's 2 sig fig. The answer is 110 cubic centimetres, and that's it. Normally worth about 3 marks for that. 1 to work out the radius, 1 to plug into the formula, and 1 for your final answer to 2 significant figures. Very, very basic. Let's look at this one over on the right hand side. Well, this diagram here represents a sweet, which is a sphere, and the outside here of it is covered in chocolate to a depth of 3 millimeters, and the question says calculate the volume of the chocolate used for this sweet. Okay, although it's 2 circles, we'll actually be working out the volume of the spheres for this, okay, because the sweet is actually in 3 dimensions, and obviously the chocolate's round outside. So this type of question, very, very popular, and the type of question this is big volume, take away small volume. Okay, so let's work out the big volume first. V big, right? VB for big. So we're going to work out the whole of this sphere outside the big sphere. So for a sphere, again, you're given this formula in the exam because it's not a prism. 4/3 pi r cubed. So to work that out, we have 4/3 pi times the radius. Now, in the question we're told that the diameter is 24, so the radius must be half of that, which is 12 cubed. And we simply, again, plug that into our calculator and come up with our answer. So let's just do that. That's 4 divided by 3 times pi times 12 cubed. And that comes to an answer of 7,238.23 millimetre cubes, or cubic millimetres. Okay, so that's your big volume. Let's work out the small volume. Now, it's the same formula because the small one's a sphere as well, but the radius will be different. So we have to work out what the radius is going to be for this one. Well, all the way across is 24, but we take 3 mil off for this side and 3 mils off for that side. So 24 take away 3 is 21. Take away another 3 for that side. All the way across the inside is 18 millimetres. So half of that will give me the radius, so that's going to be 9. So it'll be 9 cubed for my formula. Same way again, and we just plug that into our calculator. So putting the values in. 9 cubed. That's going to give me a value of 3,053.63 cubic millimetres. Okay. And for the chocolate then, for the coating of the chocolate, the awkward volume on the outside, well, it's simply going to be volume of chocolate is equal to the big volume, subtract the small volume, and that leaves me what's left. So that's going to be 7,238.23 minus 3,053.63. And we just put that into our calculator. Again, we just work that out. So 7,238.23 minus 3,053.63 gives me a final answer of 4,184.6 millimetres, cubic millimetres. Now, again, we're asked in the question to take two significant figures. So there's my 4, so I can put that as my first significant figure. My second significant figure is the 1, but that's an 8 beside it, so that changes to a 2, the rest go to 0, and we don't need the decimal part. So our final answer is 4,200 cubic millimetres. And that's big volume minus small volume. I say very, very common to come up, and I would encourage you to make sure that you can do that type of question. As I say, it's just so common that I think you can't afford to leave that one out for your exam. Okay, right, the next one I'm going to do with you is composite volume. Now, composite volume is a complicated shape that's made up of basic shapes. So this one's a child's toy, and it's made up of a cone shape and half a sphere. Okay, half a sphere. So it looks something like that, and the whole overall height of the whole toy is 17. So that's 17 centimetres for the whole bit. And across the way, now this is not drawn to scale, is 12 centimetres. And the question says, work out the total volume of the toy. Well, very similar to this one over here, but we're not going to be taking it away this time. We're going to be adding it because we've got the cone and we've got half a sphere, which is called a hemisphere. We've got these two bits, and we don't take them away because we want these two bits. In that question, we didn't want the middle bits, that's why we took it away. So back to this one, volume total is equal to I like to just draw the cone. It's called a strategy mark. So my cone plus half a sphere. And that's meant to be half a sphere. Okay, so cone, well, we know that volume, so that's the volume of a cone plus the volume of half a sphere. So I'll put S for sphere. So what's my formulas? It's a third pi r squared h for the cone plus 4/3 pi r cubed for the sphere, but we don't have a sphere. It's half a sphere, so we need to put half of that. So that's us all sorted out now. We just have to work out various wee bits here and add the answers together. So let's work out what we've got. Well, the radius all the way across is 12, so the radius must be 6 centimetres. The height, well, the overall height is 17, and we know the radius of the hemisphere is 6, so this bit down here, the wee dotted line that I put in here, must be 6, so the height of the cone must be 17 take away 6, which turns out to be 11 centimetres. So that's everything we need. Just plug it in now. So it's a third pi 6 squared times the height, which is 11, plus, well, a half of 4/3 is 2/3 times pi times 6 cubed. And we just work out these individually. So let's work them out. So we've got a third times pi, 6 squared is 36, times 11. So that's going to give me a value of 414.69 to 2 decimal places, plus, now do the sphere, half a sphere, so that's going to be 2 divided by 3 times pi times 6 cubed this time, and that's going to give me a value of 452.39 to 2 decimal places. And all we do now is we add these two values together, and that's going to give me a grand total of 867.08 to 2 decimal places, and that's cubic centimetres. But again, the question says give your answer to 2 significant figures. Well, that's going to be 8. There's a 6, 7 beside it, so that 6 changes to a 7. The rest go to 0, we don't need the decimal places. So that's our final answer. We've got 870 cubic centimetres. Okay, that's called composite volume. The final one I want to do with you is a working backwards type question. Well, that's what we call it, because in the working backwards type we're given the volume and we work back to find either a height or a length or something. So let's look at, draw a pyramid. Pyramid doesn't come up very often, but we may as well try it anyway, just in case it does come up. So this is me trying to draw a pyramid. Say the height's up here somewhere. So that will connect to here. That will connect to here. This is meant to be a 3D diagram. And this one will connect to here. And the last one will connect up to there. Okay. A wee bit smudged, but you get the idea. Now, the bottom part of it is meant to be a square. So I'll just put in the values. And the question says, if the volume is 138 cubic centimetres, then calculate the height. So we have to work out the height for that pyramid. And it's a square based pyramid. Okay, so how do we go about that? Well, you have to have good working knowledge of changing the subject and solving equations for this. So, first thing, well, it's not a prism, therefore you will be given the formula in the exam. So any pyramid, the volume is a third the area times the height. Now this area is the area of the base. Now we're told in the question this is a square. It doesn't look like a square really there, but it is a square, it's meant to be a square. So what do we know? Well, we know the volume, and we can work out the area of the base because it's a square. That's easy to work out. So we just have to rearrange and find the height. So we'll have 138 is equal to a third, 6 times 6 times the height. Well, that's going to be 138 then, is equal to, well, a third of 6 is 2, 2 6s are 12, so that's going to be 12h. So rearrange, swap the formula around, and then divide both sides by 12. And when you do that, it comes to 11.5 centimetres. So the height is 11.5 centimetres. That's all the types that I can think of for volume at National 5 level. So if you look through the past papers and you start doing all the past paper questions, you'll find that all the questions there are covered for you. It's all the same type of idea. Okay, so most basic one you can get, basic volume, a simple shape, and you simply shove in your numbers, normally having to work out the radius because they usually give you a diameter and you have to work out the radius for that, but it's very, very basic. 2, well, composite volume, that's where you have a complicated shape and you break it into basic shapes. That's that question here. Again, quite often they give you half a sphere, so you've got to remember to half. Once you work out the sphere, you have to remember to half it. That's quite common as well. So composite shapes, it's basic shapes added together normally. 3, big volume minus small volume. Again, a very popular. I would bank on that coming up and make sure you can do all these, because the questions are actually very easy once you get into them. And the last one, working backwards. Again, very popular as well. Okay, so any one of these, normally 2 of them, will come up at some point in your National 5 exam. And remember, final part of the question, answer to any of these, answer normally 2 significant figures. Normally ask you that in the question, which is an extra mark in the exam. So don't forget that wee bit. There's no point in going through all this and getting maybe 4 marks for a question and forgetting to put it to 2 significant figures for the last mark in the question. Okay, now I think the only one I didn't really do with you was the prism shape. And all you do with a prism shape is you work out the cross-sectional area and you times it by the length of the height. The ones are very basic. That would come under your basic volume, really, and that. Okay, so I worked through that for your exam. I wouldn't leave it out because it comes up every year and it's normally 2 questions. Okay, as I said to you, you normally get the basic one, and then any one of these could come up in the second paper.